What would you notice first if you quietly slipped beyond the edge of our solar system, past the last breath of sunlight, into space where distances are measured in years? Tonight on Fall Asleep to Astronomy, we drift toward Proxima Centauri, the nearest star beyond our own, a small red ember just 4 light-years away, waiting in the dark. As we imagine this silent crossing between worlds, each mile stretches thinner, each thought grows lighter. Nothing rushes here, only the soft curiosity of how far next door truly is. If this gentle journey brings you calm, a quiet, like and soft subscribe. Help others find their way here. When you're ready, we'll begin together, slowly and warm. Every beam of sunlight that brushes your skin began its journey about 8 minutes earlier. It feels immediate, like a greeting signed just for you, yet it is already a little piece of the past. If we could somehow climb aboard that warm ray and drift with it into space, chasing its fading glow, we would begin to feel how unreachable the stars truly are. Light is astonishingly swift, fast enough to circle Earth about 7 times in a single second, and yet even at that speed, it needs more than 4 whole years to cross the gulf between our Sun and Proxima Centauri, the next star beyond our own. When we stand in daylight, we are not really seeing now. We are reading a delayed message from the heart of the sun. The sunlight that shimmers on the oceans today began in the sun's core more than 10,000 centuries ago. Down there, photons wander through searing plasma, bumping and scattering from one charged particle to another in an endless, tangled dance. What starts as the fierce birth of light in a furnace of hydrogen takes hundreds of thousands of years to drift outward, changing direction so many times that escape becomes a slow, wandering climb. By the time that light finally reaches open space and crosses the emptiness to touch your face, entire eras of human history have come and gone. Cities have risen and crumbled. Languages have transformed. Beliefs and stories have been forgotten and replaced. Each photon that reaches you is a tiny survivor of that long journey, carrying the memory of the moment it was made. If we could ride one of those ancient travelers as it leaves the sun, we would slip past the soft blue shell of atmosphere, past the glittering ring of satellites, until Earth shrinks into a small blue bead wrapped in thin white clouds. The moon would fade into a pale, distant coin. The sun, so overpowering from the ground, would begin to change character. Its light would sharpen, turning whiter and colder. The blaze that once filled our sky would gradually shrink into something more like a lantern hanging in a vast, dark hall. With no air to stir the starlight, the familiar twinkling would vanish. Stars would shine with a steady, unwavering clarity. Out here, time feels stretched, not because it truly slows, but because so little happens to break it into pieces. In this deep quiet, light becomes our storyteller. It carries clues about where it came from, how far it has traveled, and what it has brushed against along the way. Scientists have learned to read this silent language by splitting light into its colors and watching how those colors shift and fade. From the pattern of that spectrum, they can tell what a faraway star is made of, whether it is moving toward us or away, and whether a hidden planet is circling gently in its glow. Every photon carries a subtle signature, a kind of cosmic fingerprint etched in color. For all its speed, though, light is still finite. The farther away something is, the longer we must wait for its story to arrive. That delay turns the night sky into a time machine. To look at the stars is to look backward. We never see the universe as it is in this instant, but as it was when the light left those distant suns. The sky above you is a gallery of vanished moments, each star a relic shining on in endless replay. Even the sun belongs to this illusion. When you feel its warmth, you are feeling something that began before you, traveling patiently through space just to reach you now. Proxima Centauri, the closest star to our sun, shines from a distance of about 4.24 light-years. By the standards of astronomy, that makes it a near neighbor. Yet if we launched a spacecraft tonight and aimed it straight at that star, we would not live to see it arrive. Even our descendants' would only be a tiny fraction of the 10,000 generations that would pass before the journey ended. 4.24 light-years may sound modest, almost friendly, but each light-year stretches nearly 10 trillion kilometers. That is such an enormous distance that even our fastest spacecraft, the Voyagers, racing at more than 60,000 kilometers per hour, would need over 75,000 years to reach it. The light from Proxima that shivers in our telescopes tonight began its journey when powered flight was still just a fragile dream in human minds. By the time it reaches us, that light is already history, showing us the star as it once was, not as it is now. Proxima itself belongs to a small gravitational family, along with Alpha Centauri A and Alpha Centauri B, two golden stars, not so different from our own. It forms a triple system. Proxima is the faint one, a red companion circling far from its brighter siblings, like a single ember drifting at the edge of a campfire. Compared to our sun, Proxima is smaller, cooler, and dimmer. Its light is a soft red rather than a bright white gold. It can be restless, throwing off sudden flares of radiation that would be harsh to any nearby worlds. Yet in another sense, it is far more patient. While our sun will live for billions of years before swelling and fading, a red dwarf like Proxima can burn steadily for trillions of years. Long after our solar system has cooled and dimmed, Proxima will likely still be glowing in the dark, quiet, and enduring. Between us and that small star stretches the interstellar medium, the thin, invisible ocean that fills the space between suns. It is so sparse that, on average, the distance between two lonely atoms can be wider than the length of a football field. And yet, it is not truly empty. Wisps of gas drift there, mostly hydrogen, along with traces of carbon, oxygen, and other elements. Fine dust grains float through it as well. These are the raw materials of creation, waiting for gravity to slowly gather them into new stars, planets, and perhaps, someday, new homes. The same elements that build our bones and blood wander through that darkness, unbound and seemingly eternal. To imagine crossing that gulf in a single lifetime is to imagine a technology we do not yet have, and a courage we are only beginning to understand. If we could stand near Proxima and look back at our own sun, we would see it as a faint star among many, one point of light in a crowded sky. Our familiar world would be reduced to a memory and a direction. Proxima itself is a red dwarf star, a restless ember that flickers and flares. Its storms can peel the air from worlds that orbit too close, stripping away atmospheres that might have once sheltered oceans and skies. Yet for all its moodiness, its glow is steady on timescales that make human history seem like a single breath. In the unimaginably distant future, when stars like our sun have burned through their fuel, red dwarfs like Proxima will still be shining, quiet witnesses to the long story of the galaxy. There is a humbling irony here. The nearest star beyond our own is, for us, unreachable. With the engines we know how to build, its warmth is forever out of reach. Its light, a distant whisper at the edge of our sky. And yet, it is always there when we look up, its faint red presence woven into our dreams of crossing the void. The distance between Earth and Proxima is not just a span of kilometers or years. It is a reminder that our everyday sense of near and far does not apply out here. The scales of space pull us out of our instincts and into imagination. When we let our thoughts travel to that tiny point of light, we are already partway there, carried not by rockets or sails, but by the simple, stubborn act of wondering. Leaving Earth, in that sense, is not about escaping anything. It is about seeing more clearly where we are. As a spacecraft rises through the atmosphere, the familiar blue thins and deepens. The horizon curves gently, and Earth slowly reveals itself as a whole, a small, luminous sphere floating in a vast dark ocean. Clouds curl over its surface like soft white brushstrokes. Continents rest under a thin golden edge of sunlight. From this vantage, all the places we argue about, all the borders we defend, collapse into one continuous landscape. It is beautiful, but also incredibly small. The realization arrives quietly. This is everything. Every story we have told, every song sung, every quiet moment shared has taken place on that fragile, glowing world. Higher still, there is no air at all, only silence and starlight. Night and day lose their old meaning. While one half of the planet basks in fierce brightness, the other is wrapped in shadow. Lightning flickers across the dark side like distant camera flashes. The faint glow of cities appears as clusters of tiny embers scattered across land masses, each one a sign of lives unfolding far below. Looking down, it is hard not to feel both love and humility. We are caretakers of something delicate, suspended between the warmth of the sun and the cold of infinity. Many astronauts speak of a deep shift in perception here, often called the overview effect. From orbit, political lines vanish. You cannot see nations, only coastlines, mountains, and rivers. Humanity appears as a single species sharing a single home. Conflicts that feel enormous on the ground seem to shrink against the backdrop of the cosmos. What grows instead is a sense that life is rare and precious, and that we are more connected than we usually remember. Far above the last wisps of air, gravity's grip still holds us close to Earth, but its presence feels gentler. Satellites drift overhead like silent lanterns, sliding along their invisible orbital paths. The International Space Station moves among them, a bright speck where humans float and work in a place our bodies were never meant to inhabit. Its thin walls separate warm breath and friendly voices from a vacuum that would be instantly lethal. Beyond that, the realm of the moon begins. Our first companion circles us in quiet loyalty, reflecting sunlight back toward Earth and turning dark water and stone into silver on clear nights. Every real journey outward, whether it is a robotic probe or a human mission, passes through the moon's domain. Its presence is a gentle reminder that we have already taken first steps away from home and that more steps may follow. But the edge of our solar shore lies further out still. It extends across the orbits of the planets, through the invisible tides of Earth's magnetic field, and all the way to the boundary of the heliosphere, where the sun's breath of charged particles finally falters against the thin wind of the wider galaxy. Beyond the moon and Mars, sunlight softens into silver. Radio signals stretch thinner. Silence begins to feel almost physical, like a soft pressure against the skin of a spacecraft. In this region, there is no sound in the way we know it. Without air or water, nothing carries a shout or a song. What moves instead are invisible fields, magnetic, electric, gravitational threading through the darkness. They curve around planets, spiral outward from the sun, and slowly mingle with the forces that fill the interstellar medium. We cannot hear their music, but our instruments can feel it, sensing the density of plasma, the shifting orientation of magnetic lines, the gentle pulse of the heliosphere. This is where our robotic explorers drift now. Voyager 1 and Voyager 2, small, aging spacecraft launched in the late 1970s, glide steadily through this quiet sea. Their antennas still send faint messages toward Earth, each signal taking more than 20 hours to arrive. By the time those photons reach us, they are so weak that giant radio dishes on 3 continents must listen with extraordinary patience, straining to catch every whisper. Each transmission is like a note tucked into a bottle and thrown into a vast dark ocean. Against all odds, the bottles keep finding their way home. Out here, the silence is not truly empty. It is alive with subtle motion. Streams of dust drift through the dark like invisible rivers. Each grain, smaller than a speck of smoke, carries the memory of ancient collisions and shattered worlds. Sometimes, one of these tiny particles strikes the skin of a passing spacecraft, releasing a microscopic flash of light, a brief reminder that even in nothingness, something always moves. The sun still shines somewhere behind us, but its authority has faded to a memory. Daylight becomes an old idea, something that belongs to another place. Out here, night is everything else. The stars grow sharper, more numerous, like tiny pinpricks in a velvet curtain. The Milky Way no longer looks like a hazy band of light, but like a vast, ghostly river made of billions of suns. Each one could be a destination. Each one could hold its own skies, its own questions. If you close your eyes and imagine yourself drifting between Mars and Jupiter, the silence begins to feel like a kind of music, slow and endless. Time stretches, seconds soften into minutes, minutes blur into years, and the usual sense of how long quietly slips away. Space has no edges here, only distances that lengthen and light that thins. The scales are so large that the human mind simply lets go. Moving through the quiet between worlds feels like walking through the memory of creation itself. You start to sense that everything, stars, planets, and even the matter that makes you, was forged out of this same deep stillness. And as you drift deeper into it, you realize the universe rarely shouts its wonders. It whispers them. And only in this kind of quiet can we really hear. Farther out, we approach the far frontier of our solar system, where Neptune's faint blue glow sits near the edge of sunlight. From a distance, it no longer looks like a world, but like a small blue coin hanging in the dark. Its methane clouds swirl slowly over an atmosphere so cold that winds can roar at more than 1,000 miles per hour, racing through frozen air. Neptune is the last giant of our planetary family, a silent sentinel standing guard at the border of our star's bright domain. Beyond Neptune stretches the Kuiper Belt, a drifting cathedral of ice and stone. These are remnants of the solar system's earliest days, fragments that never grew into full-sized planets. They have waited here, untouched, for billions of years. As we move past Neptune's orbit, the sun's light dims to a pale spark, too faint to cast a proper shadow. The warmth that once wrapped Earth in comfort now feels distant, almost mythical, like a story told about a fire we can no longer see. If you imagine reaching out a hand here, the cold would bite through even the thickest protection. At this distance, the sun's power, the force that drives every storm, every tide, every heartbeat on Earth, has dwindled to a gentle murmur, barely strong enough to kiss the hull of a passing ship. The Kuiper Belt is both a graveyard and a nursery. Ancient objects sleep in long, quiet orbits, circling in the dark. Worlds like Pluto, Eris, Haumea, and Makemake drift here, frozen relics carrying the chemistry of beginnings. Their surfaces are dusted with nitrogen frost and thin layers of hydrocarbon ice, reflecting the faint sunlight like pieces of old glass hidden in snow. To look at them is to look backward in time, into a frozen memory of the age when dust and gas first thickened into worlds. Beyond this icy ring lies something even more mysterious, the scattered disk, where the sun's gravity begins to loosen its grip. Out there, orbits stretch so long that a single loop can take centuries, even millennia. Comets sleep in elongated paths, waiting for the gentle nudge that will send them inward, back toward the warmer regions. When they finally return, they flare briefly into brilliance near the inner planets, shedding tails of gas and dust, riding shining arcs across the inner sky, before retreating once more into the dark. Some will never come back at all, thrown adrift forever by the tug of passing stars. When we move beyond Neptune's realm, the solar system slowly turns into a memory. The planets vanish behind us, swallowed by distance. The sun shrinks until it is just one pale star among countless others. It is a moment of deep humility. Everything we have ever known, every ocean, every forest, every city, every life, now fits inside a single shimmering point of light. From this vantage, the stars no longer look like decorative specks scattered over a dome. They look like destinations. Each one is a sun in its own right, perhaps with planets, moons, and storms of its own. Each might carry stories we cannot yet imagine. Between them lies the interstellar medium, a thin breath of hydrogen, a dusting of high-energy particles, the faint afterglow of ancient explosions and the early universe. Crossing Neptune's orbit is not truly the end of our solar system. It is the beginning of the great in-between, the long bridge that connects one star to the next. The space beyond is not empty. It is waiting for our ships, our signals, our quiet questions. And as we leave Neptune behind in our imagination, we begin to understand something gentle and important. To go farther is not to abandon home, but to expand it. At the edge of the sun's influence, an immense, invisible bubble of solar wind presses outward against the thin gas between the stars. For billions of miles, the sun's breath has flowed in all directions, a constant stream of charged particles called the solar wind. This wind shapes a huge shield around our planetary system, the heliosphere, a protective cocoon that softens some of the harsh radiation drifting through the galaxy. But even the sun's reach has its limits. Eventually, the outward push of the solar wind weakens until it meets the steady pressure of interstellar space, a vast ocean of gas, plasma, and tangled magnetic fields that flows between the stars. The delicate boundary where these two forces balance is called the heliopause. If you could cross it, nothing dramatic would announce the moment. There would be no wall, no glowing edge. One instant, you would still be under the faint shelter of the sun's influence. The next, you would be drifting in the domain of the galaxy itself. Yet the difference would be profound. Inside the heliosphere, most of the particles that brush past you were born in the sun's fire. Outside, they come from elsewhere, from supernova explosions, from stars that lived and died long before Earth formed. To step past the heliopause is to step into a history older than our own star, older than our planet, older than any human thought. When Voyager 1 reached this threshold in August of 2012, it became the first human-made object to leave the sun's protective bubble. Its instruments registered a sudden change. The solar particles faded away, replaced by the signature of interstellar ones. The spacecraft had entered a region that had never felt the direct breath of our star, a place untouched by its wind. Its faint signal, taking more than 20 hours to reach Earth, carried news from a realm humanity had only guessed at. Out here, sunlight is almost an afterthought. The solar wind no longer rules the environment. Instead, magnetic fields twist and sway according to the larger pattern of the Milky Way. Charged particles drift slowly through space, their paths shaped by distant stars we cannot see. The space beyond is not silent, but filled with a kind of quiet static, the hum of radiation, the echo of far-off cosmic rays. It is a symphony, too soft for ears, but not for instruments. Voyager's sensors recorded it as a low, steady tone, the faint voice of interstellar space. Imagine standing at that invisible shoreline, the sun behind you, the galaxy ahead. Behind lies everything familiar, the planets and their moons, the warmth of day, the blue and white face of Earth. Ahead lies everything else, billions of suns, uncounted worlds, and the delicate web of starlight connecting them. Crossing the heliopause is not just a change in location, it is a change in belonging. Inside, we are children of one star. Beyond, we become, at least in spirit, citizens of the galaxy. This boundary is the true beach of our cosmic island. It marks the place where the tide of the sun's influence ebbs and the open sea of the universe begins. So far, we have only touched it with a few fragile machines, but it is easy to picture a distant day when our descendants will pass it in person, not as wanderers lost in the dark, but as travelers extending the idea of home. For beyond the heliopause lies not the end of the sun's light, but the beginning of everything else. Voyager 1 crossed this border, carrying something precious, a golden record, a quiet bottle set adrift in the cosmic ocean. Launched in the year 1977, Voyager 1 and its twin, Voyager 2, were sent out not only to visit the outer planets, but also to carry a story. Each spacecraft holds a golden disk designed to last for perhaps 1 billion years, a durable time capsule of Earth. Etched and encoded on that record are 115 images, greetings, spoken in 55 human languages, a selection of music from many cultures, and the sounds that cradle everyday life on our world. Wind in trees, thunder, birds calling, a baby's cry, waves on a shore, human laughter. The record opens with a greeting from the Secretary General of the United Nations, followed by the simplest and most universal rhythm anyone might recognize: a human heartbeat. The music ranges from traditional songs of Senegal and a Peruvian wedding melody to a Navajo night chant, from Johann Sebastian Bach's Brandenburg Concerto to Chuck Berry's Johnny B. Good, a bright burst of rock and roll flung into the dark. Carl Sagan, who helped lead the team that created the record, called it a bottle cast into the cosmic ocean. It was not made because we expected someone to find it. It was made because hope is part of who we are. Now, Voyager 1 drifts more than 24 billion kilometers from home, moving outward at over 60,000 kilometers per hour. Its instruments are aging, its power slowly fading, yet it still speaks. Its radio signal is weaker than the background static of a falling snowflake, and still, Earth's deep space network listens, using giant radio dishes spread across several continents, concentrating patiently on that faint whisper. Each moment, Voyager sails a little farther into the night. Inside its quiet frame, the golden record continues to turn, carrying the sounds of rain and surf, and breathing hearts through the cold vacuum between stars. If, one distant day, perhaps millions of years from now, another intelligence were to find it and decode its grooves, they might hear the sound of a mother comforting a child, friends laughing, waves crashing against a rocky coast. In that moment, they would know that someone, somewhere, once lived here. But the record is not only a message to them, it is also a message to us. It reminds us that even in our early days, as a spacefaring species, we looked outward with curiosity and tenderness. We wanted not just to measure the universe, but to introduce ourselves to it. We wanted to say that we are not only builders of machines, but makers of songs and stories and love. Every heartbeat and melody carved into that golden disc quietly says the same thing. We existed. We felt wonder. We reached toward the stars. As Voyager continues its long path toward the constellation of Ophiuchus, in roughly the direction of Proxima Centauri, it carries that whisper, a heartbeat from a small blue planet, still echoing in the dark. Whether or not anyone ever finds it, the act of sending it was enough. To speak into the void is to declare that we are alive, and that life, however fragile, dares to be heard by the cosmos itself. The path between the stars is not empty. It is a river of charged particles, magnetic tides, and cold, drifting clouds of molecules. To travel it would be to surf the invisible, to sail on a sea made of space itself. For a long time, people imagined space as a perfect vacuum, an endless nothing. But even in the deepest dark, the universe breathes. The space between stars is filled with a whisper-thin medium, mostly hydrogen and helium, laced with dust and threaded through with energy fields. A single cubic centimeter out here might hold only one lonely atom. Yet when you stretch that almost nothing across trillions of kilometers, it becomes an ocean. It ripples and flows, sculpted by the gravity and magnetic fields of entire galaxies. These are the invisible currents of the cosmos, forming a subtle, shifting weather system that no eye can see but every traveler must navigate. Streams of charged particles spiral along magnetic field lines, bending and twisting through the Milky Way. Shock waves from long ago supernova explosions push through this medium, stirring vast, cold clouds of gas that may one day gather, collapse, and ignite as newborn stars. To move through space is to drift across unseen rivers. Currents of particles and fields slip past in the dark, each one carrying the memory of creation and destruction together. Our sun itself sails through this galactic ocean, towing the planets along as it orbits the Milky Way at roughly 230 kilometers per second. Wrapped around it, the heliosphere behaves like the bow wave of a ship, a great bubble of solar wind that parts the interstellar medium before it. Behind, a long, faint wake of particles trails off into the dark, stretching for billions of miles. We are passengers on this ship, carried through the galaxy by a motion so vast we cannot feel it, only measure it against the slowly shifting patterns of the stars. Scientists have begun to chart these hidden flows. With radio telescopes, they listen to the faint whisper of hydrogen atoms drifting in space, mapping their soft glow across the sky. With spacecraft like Voyager and a mission called IBEX, they trace the pressure of particles striking the very edge of our solar system. Piece by piece, the data reveals a landscape that moves and breathes. There are waves of density, eddies of magnetism, great clouds of cold gas sliding like invisible icebergs through the dark. The local interstellar cloud, the thin mist our solar system is passing through right now, stretches for about 30 light years. It is a tenuous mixture of atoms warmed by the faded shockwaves of long-dead stars. If we could see these currents with our eyes, they might shimmer faintly, delicate ribbons of motion and light twisting through endless night. A ship traveling between the stars would not move through stillness, but through these subtle tides. The challenge for future explorers will be learning how to ride them, the way ancient sailors once learned to listen to the wind and the pull of the sea. With magnetic sails or plasma shields, a future starship might one day surf on the faint breath of the galaxy itself, steering by the flows of particles and fields instead of waves and weather. The map of these invisible currents is far from complete. It is drawn, not in ink, but in radiation, gravity, and time. Each new measurement adds a soft pencil line, a suggestion of where the cosmic winds rise and fall. And like every map ever made in the name of exploration, its lines tell us as much about ourselves as they do about the world it describes. The more we learn about what we cannot see, the more we realize the universe has never been empty. It has always been alive, always in motion, carrying us quietly along its endless, unseen sea. To cross that sea, we will need better vessels than the ones we have now. Chemical rockets flare, bright and fierce, but they die quickly. They are wonderful for leaping off worlds, for reaching nearby planets and moons, but the distance between stars laughs gently at fire that burns so fast. The rockets that carried humans to the moon and sent probes into the outer solar system run on relatively simple chemistry-controlled explosions that fling metals skyward. They are powerful, but brief, like matchsticks lit in a storm. Even the mighty Saturn V, the largest rocket we have ever flown, could only push its crew a few 100,000 kilometers from Earth before its tanks ran dry. Those journeys were historic, but the gulf between stars is not measured in thousands or even millions of kilometers. It is measured in light years, stretches of space so huge that each one holds trillions upon trillions of kilometers. No chemical flame, however bright, can hope to cross that distance in a human span. If we truly want to touch another sun, we must imagine a new kind of fire. One possibility is nuclear fusion, the same process that makes stars shine. Instead of burning fuel in the ordinary sense, a fusion engine would fuse light atoms such as hydrogen, merging them and releasing enormous amounts of energy. You can imagine a ship driven by miniature suns, each brief fusion reaction giving it a push through the dark. Visionary projects with names like Daedalus and Icarus, Interstellar, have already sketched designs for vast craft, perhaps the size of small cities, fueled by pellets of deuterium and helium-3. If such a fusion drive could be perfected, it might reach speeds close to 10% of the speed of light. A journey to Proxima Centauri that would take 75,000 years with today's technology might shrink to something closer to a few human lifetimes. That is still long, but it begins to sound like a story we could tell in one continuous thread, passing it from one generation to the next. Then there are solar sails, delicate, gleaming sheets that catch the pressure of light itself. Light has no mass, but it does carry momentum, a gentle push that never stops. A sail wide as a great field could ride sunlight outward, slowly but steadily leaving the solar system behind. On its own, that push is slight, yet it never turns off. And if we help it, if we shine powerful, focused beams of laser light from Earth or from orbit, we can turn that steady shove into something far more dramatic. This is the heart of an idea called Breakthrough Starshot, a real project already under study. Instead of one big ship, It imagines a fleet of tiny probes, each no larger than a chip of electronics, far smaller than your hand. Attached to whisper-thin sails and launched into space, they would wait for a burst of laser light from a vast array on Earth, perhaps delivering 100 gigawatts of power for only a few minutes. Under that sudden, intense beam, each sail could be pushed to perhaps 1/5 of the speed of light. At such a speed, these tiny craft could cross the gap to Proxima in a little more than 20 years. They would not carry humans, but they would carry our curiosity, our instruments, our questions. They would be our first messengers between stars. More speculative still, our antimatter drives, engines powered by the most efficient energy release known in physics. When matter and antimatter meet, they annihilate, turning all of their mass into pure energy. Just a few grams could, in theory, power a ship for a very long time. The problem is that antimatter is incredibly rare. We can make tiny amounts of it in particle accelerators, but storing it and producing it in useful quantities is a challenge that belongs more to tomorrow than today. Still, the idea remains on the edge of our dreams, a bright possibility that keeps engineers and physicists wondering what might one day be possible. Beyond even that horizon lie wilder concepts, warp drives that would bend space itself, compressing the distance in front of a ship while stretching it behind, buzzard ramjets that scoop up thin interstellar hydrogen as fuel, engines that might draw power from tiny black holes. Each of these ideas sits at the boundary between hard physics and imagination. Some may never leave the realm of theory. Others might, someday, surprise us. But under all of them runs a deeper engine, one that does not run out. The true fuel for interstellar travel is curiosity. Every design, every experiment, every wild idea about crossing the night begins with a very simple question: what if we could? The stars wait in their patient way, and the equations are already written in the language of nature. Somewhere between science and wonder, we are learning how to ignite the next great flame, not one that burns out quickly, but one that carries us beyond the limits we once thought were fixed. A light-driven sail, no thicker than a whisper, could someday ride the pressure of photons pushed by lasers from our own planet. At a speed of roughly 1/5 of the speed of light, such a craft could reach Proxima in about 20 years. A fragile ship carried by radiance alone. It sounds like something out of poetry. A vessel made not of roaring engines and heavy tanks, but of light and reflection. The idea is simple and profound at the same time. Use the momentum of photons, the tiny packets of light that pour endlessly from stars, to push a spacecraft forward. Each photon carries almost no mass, almost no push on its own. But when billions and billions of them strike a reflective surface, they can provide a steady, continuous thrust. Like wind swelling a sail, light itself becomes an engine. For this to work, the sail must be unimaginably thin, perhaps only a few atoms thick, made of a material so reflective it seems to shimmer between substance and energy. You might picture it unfurling in space like a sheet of silver silk, its surface wide enough to catch even the faintest sunlight. On its own, that sunlight might not be enough to carry it to another star, but with help from a focused beam of light, it could skim along a pathway of pure energy across the void. This is the dream at the heart of Breakthrough Starshot. A group of scientists, engineers, and dreamers came together in the year 2016 to take the old, impossible question and treat it like an engineering problem. Instead of one massive ship, they proposed sending thousands of tiny ones. Instead of carrying fuel, These star chips would ride on light. Each miniature probe would be thinner than a wafer, only a few grams in mass, yet packed with cameras, sensors, navigation systems, and a tiny radio to send its findings home. Attached to each would be a sail several meters across, designed to catch the push of laser light from Earth. The laser array itself would be extraordinary, many separate beams working together, carefully synchronized to form one immense pulse of energy. For a few minutes, they would shine upward, pushing the fleet of sails to a tremendous speed. After that short burst, the lasers could fall silent. The probes would coast into the dark, carried forward by the momentum of that single bright moment. There would be no engines firing along the way, no fuel tanks to refill, only time and distance. If all went as planned, the tiny fleet would reach the Proxima Centauri system in about 20 years. For the first time, physical explorers from Earth, small, silent machines born of our curiosity, would pass near another sun. As they swept through the system, they could glance at Proxima b, the intriguing planet that orbits within the star's habitable zone. They might measure its magnetic field, taste the thin edge of its atmosphere, and snap hurried images as they rush by. Then they would turn their little antennas toward home and begin sending their findings back. Those messages would take more than 4 years to cross the light-year gap, but one day, fragile signals from another star system could arrive at our world. Beyond the measurements and data, there is something deeply human in this plan. Project Starshot marks the first serious attempt to look at the stars not just as distant lights, but as reachable destinations. For ages, the distance to them belonged more to poetry and myth than to engineering. Now, slowly, that distance is becoming something we can write equations for, something we can design around. In that sense, each tiny probe is more than an instrument. It is a message. Each sail will be smaller than a butterfly, yet together they will carry one of our oldest desires, the wish to see what lies beyond the horizon. They will drift through interstellar night for decades, silent and patient, until one day they cross into the faint red glow of Proxima. When that happens, the story will not just be about a set of machines completing a mission. It will be about us, a species that learned how to turn light into a ship and distance into an invitation. All of this unfolds under a sky that is already sending us its own messages of light. The glow we see from Proxima tonight began its journey when the world was slightly different, when people were still walking through days and dreams that have already faded from memory. Every star is a time machine. When you look up at the night, you are not seeing now, you are seeing then. Each bright point overhead is a delayed signal, a postcard from the past carried across the slow currents of space. Proxima Centauri's faint red light, too dim to see without a telescope, left the star about 4.24 years ago. That means when those soft crimson photons began streaming toward us, Earth was almost 5 trips around the sun younger than it is in this moment. Seasons shifted, clouds wandered, whole lives unfolded, all while that light crossed the void, unaware of the stories waiting at its destination. It is a strange comfort to know that even the fastest thing in the universe takes years to reach us from our nearest stellar neighbor. When we finally gather that light in our telescopes, we are not seeing Proxima as it is now, but as it was then. And the mirror works both ways. If someone around Proxima were watching Earth at this instant with a powerful telescope, they would not see you as you are now. They would see the Earth of years ago, the world as it appeared before these words were written, before millions of fresh stories began. Every star is a mirror, quietly reflecting history. When we study the galaxies scattered across the night, we are not just looking into distance, but into time itself. Some of those faint smudges of light are so far away that their glow began traveling long before Earth existed, before oceans formed, before any sky held clouds. The farther we look, the younger the universe becomes. At the faintest edge of infrared light, we glimpse echoes from only a few 100 million years after the Big Bang, when the first galaxies were just beginning to gather and shine. We are not merely observing space. We are watching time stretched thin, painted across a cosmic canvas. Even Proxima's humble glow carries this memory. Its light arrives as a soft red whisper, but inside that whisper is structure, tiny variations that reveal its temperature, its moods, its storms, its heartbeat. When scientists break its light into a spectrum, they are reading the star's own language. The careful pattern of hydrogen and helium, the fingerprints of magnetic flares and simmering plasma. That faint red beam is more than illumination. It is information. Each wavelength carries a sentence about what was happening there about 4 years ago in Proxima's sky. There is a quiet tenderness in that delay. It means we are never quite in sync with the cosmos. We are always seeing it as it was, never as it is. We live surrounded by ghosts of light, bathed in messages from billions of suns whose stories are still crossing the dark toward us. Every night, when we stand on Earth and look up, we are standing in a river of time. We are washed in the afterglow of what was. So when you lift your eyes to the stars, remember, you are not only looking outward, you are looking backward. You are watching an endless story arrive in slow motion. And one day, far away, light from our own sun may reach another world. Someone, or something, may look up at their sky and see us as we were 4 years, or 4 centuries, or 4 million years before. In the end, light is the universe's memory, and for a little while, we are among its witnesses. Proxima itself is a red dwarf, smaller, dimmer, and far more temperamental than our gentle yellow sun. From far away, Proxima Centauri seems calm, just a faint ember tucked among brighter stars. But that quiet glow hides a restless heart. Red dwarfs are the most common stars in the universe, making up perhaps around 70% of all stars. They are small, patient furnaces that burn their fuel slowly, not for billions of years as our sun does, but for trillions. This long life comes with a cost. Many red dwarfs are volatile, magnetic, unpredictable. Proxima's surface, though cooler than our sun's, is a churning ocean of plasma. Fields of magnetism twist and tangle there, like invisible storms coiling beneath the surface. When those fields snap, they unleash sudden eruptions of energy, waves of X-rays and ultraviolet light exploding outward into space. In March of the year 2016, telescopes caught one of Proxima's most dramatic outbursts. For a few brief moments, the star brightened by something like 1,000 times its usual visible intensity. The flare blazed across multiple wavelengths, visible light, ultraviolet, and X-rays, all at once. If a planet nearby had a clear view of the star, its sky might have lit up with a violent red dawn. On Earth, such an event would tear at our ozone layer, burning holes in our protection from radiation. Around Proxima, repeated flares like that could strip an atmosphere away, molecule by molecule, into space. And yet this same chaotic energy is part of what makes red dwarfs so fascinating. They are paradoxes, small and dim, yet capable of enormous power. Because they are so light in mass, they burn their fuel slowly and efficiently, glowing gently for timescales that make human history feel like a single breath. When our solar system has cooled, when our sun has swollen and faded, red dwarfs like Proxima will still be shining, slow and steady, in the far future of the galaxy. On the timeline of the cosmos, red dwarfs are almost eternal. Imagine, just for a moment, standing on the surface of a world near Proxima during one of its calm spells. The light would be dim and red, bathing the ground in a soft crimson glow. Noon might feel like an endless sunset. Shadows would be long and muted. Plants, if they existed there, might drink deeply from infrared light instead of the yellow and blue we are used to. The sky could be dark even in daytime, with stars still visible as pale points around the low red sun. Then, without warning, the sky might flare. A storm of energy surging from the star could brighten the heavens so quickly that new shadows would leap across the ground. High in the thin air, curtains of aurora might ignite, not just in green, but in deep reds and violets, dancing from horizon to horizon. Life beneath such a temperamental sun would need to be clever and resilient. Perhaps it would hide under oceans, beneath thick ice, or deep inside rock. Perhaps it would emerge only during the quiet intervals between storms. On Proxima b, if life exists, it would live in rhythm with a star that breathes in bursts. Danger and warmth would come from the same source. Evolution there would not favor fragility, but resilience. Organisms that can withstand long spans of calm, punctuated by sudden, intense flares, that can sleep through storms and wake when the sky settles. Proxima Centauri is not the tranquil, steady lantern we know in our own sun. It is smaller, yes, but fiercer in temperament, older in potential lifetime, and more enduring. It burns softly for eons, interrupted by flashes of fury. Each flare is a reminder that even the dimmest stars can carry tempests within them. In that faint red glow lies both peril and promise. A sun that could scour a world bare, or sustain it longer than our own star will ever burn. Orbiting within a narrow ring of distance where liquid water might exist, Proxima b is roughly similar in size to Earth. It is a potential cradle of life circling the nearest star beyond our own. In the year 2016, astronomers noticed a faint, repeating tug in Proxima Centauri's light, a subtle wobble in the star's motion. Something, unseen but steady, was pulling on it. That invisible hand was a planet, orbiting once every 11 days or so. They named it Proxima b. In that moment, the idea of a nearby habitable world shifted from dream to possibility. At about 1.3 times the mass of Earth, Proxima b appears to be a rocky terrestrial planet, the kind that can, in principle, carry mountains, oceans, and a sky. Its orbit lies within the so-called habitable zone, where temperatures could allow liquid water to exist under the right conditions. But around a red dwarf, this just right zone is complicated. Warmth there comes not from bright white sunlight, but from dim, persistent infrared glow. Daylight on Proxima b would not be golden. It would be ember-colored, a deep, soft red. Standing on its surface, if that were possible, might feel like living under an endless sunset. The sky might never turn blue. Instead, it could hang overhead in shades of dark red and purple, the light too weak and too red to scatter in the same way it does on Earth. Shadows would lie long, stretching out like fingers across the ground. Many astronomers suspect that Proxima b may be tidally locked, showing the same face to its star at all times, the way our moon always turns one side toward Earth. If that is true, one half of the planet would know only perpetual day, staring forever into the red glare. The other half would be held in endless night, frozen and dark. Between them would lie a thin ring of twilight, the terminator region, where the star would forever hover near the horizon. It is along this band of eternal dusk that life, if it exists, might find its best chance. There, temperatures could balance between scorching and freezing. Oceans might survive as liquid water. Winds could drift from the hot side to the cold, carrying air in slow planetary tides, smoothing out extremes. Within that soft twilight, clouds might form and rain might fall. Yet even in this potentially gentle zone, Proxima B's story is not one of simple comfort. The same star that provides warmth also threatens to erode the very conditions that make life possible. Proxima's flares can pour ultraviolet and X-ray radiation onto the planet, gradually stripping its atmosphere away unless something strong protects it. For life to endure, Proxima B would likely need a thick magnetic field, like Earth's, to deflect energetic particles, or a deep ocean and heavy, shielding atmosphere to absorb the star's blows. If it has those defenses, it could be one of the most remarkable refuges in the galaxy, a living world orbiting a temperamental, long-lived star. So far, telescopes have only begun to investigate this faint neighbor. We cannot see Proxima B directly. Its presence is inferred from the star's motion, from gravity's subtle fingerprints on the light. Future instruments, the descendants of observatories like the James Webb Space Telescope, may study the starlight that passes through any atmosphere it might have. From that filtered light, scientists hope to tease out delicate signatures of gases like oxygen, methane, or water vapor, chemical hints that something complex may be happening on its surface or in its seas. In this way, Proxima B is more than a distant rock. It functions like a mirror held up to us. It reflects our hope that Earth is not alone in its capacity to host life. It suggests that the spark that began here may ignite elsewhere whenever warmth and chemistry meet for long enough. In the quiet between stars, this small world circles its red sun, unseen to human eyes. It is a promise, a question, a reminder that even in the shadow of the nearest star, another kind of home might be waiting. We first found Proxima B not by sight, but by its tug. The planet revealed itself through the tiny sway it induced in its star. Even from around 4.24 light-years away, gravity left a whisper we could hear with our instruments. When astronomers search for new worlds, they almost never see them directly. The stars they orbit are too bright, overwhelming the faint reflected light of the planets. Instead, scientists listen to the quiet symphony of gravity. They watch for the way a star wobbles, just a little, when something unseen circles it. This method, called the radial velocity technique, is how Proxima B first spoke to us. In the year 2016, using an instrument known as the HARPS spectrograph in Chile, astronomers noticed an almost imperceptible rhythm in Proxima's light. About every 11.2 days, its spectrum shifted in a repeating pattern. To human eyes, the star seemed steady and still. But with precision instruments, it was clear that Proxima was moving ever so slightly, swaying to the gravitational pull of something small and close. The motion caused by the planet is tiny, on the order of about 5 kilometers per hour, slower than a person strolling along a quiet street. Even so, that gentle tug leaves marks on the starlight. As the star moves toward us, its light shifts slightly bluer. As it moves away, slightly redder. These shifts are minuscule, smaller than 1 part in 100 million, but they are enough. By measuring them carefully, astronomers could tell that a planet, roughly no larger than Earth, and much closer to its star than Mercury is to our Sun, must be there. It is a delicate and beautiful measurement. From more than 4 light years away, we can detect the faint gravitational whisper of a world smaller than our own, circling a dim, distant star. We do not see the planet directly. We feel it through the way it tugs on its sun. It is a reminder that the universe is woven together. Every world, no matter how small or far, leaves a ripple in the light of its star. There is another way we find planets, by their shadows. When a planet passes directly in front of its star from our point of view, it causes a tiny dip in the star's brightness. This is called a transit. Each transit is like a heartbeat, a regular blink in the light that reveals the planet's size, its orbit, and sometimes even hints about its atmosphere. While Proxima b does not seem to transit from our perspective, many other planets do, and through their shadows we have discovered thousands of exoplanets scattered across the sky. The beauty of these methods lies in their subtlety. We do not need to see a planet's surface to know that it is there. It is enough to notice the star's hesitation, its slight sway, its momentary dimming. In listening to these faint cues, we turn the universe into a living map of relationships. Each star becomes not just a point of light, but a system, a family, a story of companions and orbits. Proxima b came to us in that way, not as a bright dot in a picture, but as a soft, invisible nudge that said, "Something else is here." In that whisper, humanity heard something profound, confirmation that even the very nearest star has worlds of its own. The universe, it seems, is not a lonely expanse of empty light. It is full of companions, circling quietly in the dark, waiting for us to notice their gentle pull. If Proxima b has an atmosphere, its skies might glow with a dim crimson light. Days could be short, nights long, yet still just warm enough for oceans to dream beneath an unfamiliar sun. In the fragile balance that makes a world habitable, temperature is quietly decisive. Too hot, and oceans rise into vapor. Too cold, and water locks into hard, silent ice. Somewhere between those extremes, within a narrow band of balance, liquid water can flow. Wherever water can move, the chemistry of life has a chance to begin. Proxima b orbits inside this delicate zone around its small red star, close to the threshold between frozen desert and living world. Because Proxima Centauri is so faint, its habitable region lies much nearer to the star than Earth does to the Sun. From Proxima b's surface, the star would loom large, appearing perhaps about 3 times wider than our Sun does in our sky, glowing not gold, but a deep ruby red. Its light would carry less energy in bright visible colors and more in deeper reds and infrared, bathing the landscape in perpetual twilight. If the planet has an atmosphere, that air could scatter the red glow in unfamiliar ways, casting a soft, dreamlike light across rock and sea. A day there would feel strange to us. The planet's close orbit almost certainly means it is tidally locked, with one side always facing the star and the other held in endless night. The sunlit face could grow fiercely hot under constant exposure, while the dark side might be locked in deep cold. But along the thin boundary between them, the terminator, where day falls into night conditions, might soften. Winds could carry heat from the bright hemisphere into the dark, smoothing the extremes and creating a ring of permanent dusk where ice melts and water might flow. If life exists on Proxima b, it might gather in that twilight band, a narrow belt of eternal sunset where the star forever hovers near the horizon. Light would never fully fade, yet never fully blaze. It would be a world of gentle half-light, where the sky never turns blue and shadows stretch long, living halfway between day and night. Everything depends on whether Proxima b has held on to its air. Red dwarfs are restless stars. Their flares and winds can strip atmospheres from nearby planets over long spans of time. If Proxima b has lost its atmosphere, it could be a bare, airless rock, its oceans long gone, its surface scarred by particle storms. But if the planet has a strong magnetic field, like Earth's invisible shield, it might have deflected much of that violence. In that case, its air could have survived. Clouds might still be drifting through dim red light, and rain might still be falling softly into alien seas. To imagine Proxima b's temperature is to imagine a scale of possibilities. It could be frozen, it could be scorched, it could sit in a delicate middle ground. Even in the faint glow of a small red star, energy still flows, water can still exist, and chemistry can still weave complexity out of simple beginnings. One day, a future telescope may split Proxima's light and catch the faint imprint of gases in the planet's atmosphere, perhaps water vapor, perhaps oxygen, perhaps something we do not expect. That would mean Proxima b is not just another distant rock, but a cradle, a place where the universe has tried again to dream of life. Around such a star, solar flares are storms of fury, ultraviolet tempests that can sweep across entire worlds. Yet if magnetic fields hold, life might learn to hide in the twilight, tucked beneath stone and sea. Proxima Centauri, though small and dim, is far from peaceful. Its surface seethes with magnetic energy, coiling and snapping like an invisible weather pattern. Flares, bursts of radiation, and charged particles can erupt without warning, brightening the star hundreds of times over in minutes. For a world like Proxima b, clinging nearby, each outburst would matter. A strong flare could flood the sky with X-rays, break apart molecules in the atmosphere, and wash the surface in harsh ultraviolet light. We think of our own sun as steady, but Proxima shows how fragile that steadiness is. Red dwarfs are famous for their tempers. Their smaller size and cooler temperature allow magnetic loops to dominate their behavior. When those loops tangle and snap, they release energy equal to millions of atomic bombs. These storms are not rare. They are part of the star's everyday life. If Proxima b ever had an atmosphere, these repeated blows would have tested it constantly. The stellar wind, a steady stream of charged particles, would slam into the planet's magnetic field, if it has one, like waves against a cliff. Without a strong shield, the wind would slowly strip away the air, atom by atom. On Earth, our magnetic field, generated by molten metal churning deep below our feet, protects us from the same fate. It guides much of the solar wind toward the poles, where some of it paints the sky with auroras. If Proxima b has a similar shield, its night sky might glow with curtains of crimson and violet, auroras woven by the same storms that threaten its survival. Even under such harsh conditions, life might endure. On Earth, hardy organisms flourish in places once thought impossible, near boiling vents on the ocean floor, within glacial ice, inside rocks soaked in radiation. Life does not always need sunlight. It can live on chemistry alone, drawing energy from minerals, heat, and slow reactions. On Proxima b, life, if it exists, might have retreated underground or beneath deep oceans, protected by rock and water. There, in a world of faint echoes and slow change, microscopic communities could feed on chemical gradients, warmed by the planet's interior. They would live in rhythm with a stormy sun, sheltering during flare seasons and expanding in calmer epochs. For all their violence, Red dwarfs offer something our sun cannot: immense spans of time. Stars, like ours, burn bright and end within roughly 10 billion years. Red dwarfs can glow for trillions, even if Proxima B's surface has fallen silent. Worlds around other red dwarfs may one day host life, given patience beyond measure. New planets might form, older ones might shift into gentler orbits. The story of such systems is not short, it is written in ages. The winds of a red dwarf are not only forces of destruction, they also sculpt and refine. They test what can endure. If somewhere beneath Proxima B's battered surface, a single cell still persists, it would stand as a quiet declaration. Even in the fiercest winds, the universe keeps trying to live. To our eyes, Proxima's glow is faint. To infrared vision, it would burn like an ember, steady, patient, old. Our sight is tuned to the light of our sun, a narrow band that passes easily through Earth's air, from violet to deep red. That seems natural to us because it is what we know. Our world, our colors, even the way we name day and night, all grew beneath a yellow star. Proxima tells another story. Its light leans into longer wavelengths, much of it invisible to human eyes. Standing on a planet under Proxima, you might see a sky forever painted in shades of crimson dusk. Shadows would be soft and long, horizons dim. It would feel like evening that never quite gives way to noon. But if your eyes could see infrared as clearly as we see blue and green, the world would look very different. The star would blaze brighter, an ember at the center of everything. Rocks and soil would glow faintly with stored heat. The night side of the planet would not be perfectly dark, but threaded with low warmth, visible in those deeper colors. Astronomers use infrared to peer through dust and time. In that light, star-forming clouds become transparent. The birthplaces of suns glow softly. The faint heat of distant galaxies, stretched by the universe's expansion, can be traced. Telescopes like the James Webb Space Telescope were built to catch that ancient, reddened light, to see not only farther, but in a different way, to read the chemical fingerprints of exoplanet atmospheres and search for signs that something living might be there. If life has adapted beneath Proxima's glow, its senses would likely differ from ours. Its eyes, if it has eyes, might favor deep red and infrared. Its plants might be dark, crimson, or almost black, designed to drink every possible photon from a meager sun. To such beings, Proxima's dimness would not feel dim, it would feel generous and steady. This same invisible warmth glows from dust, grains between the stars, and from wisps of interstellar gas. It is the quiet radiance of the universe, not blinding, but persistent. Much of the cosmos speaks in these low, soft wavelengths, beyond our natural sight. Our senses sample only a sliver of reality. Proxima's ember hints at the rest, a wider tapestry of light we are only beginning to learn how to see. For most of the journey between stars, there are no planets to break the view, no obvious markers, only the distant lanterns of suns. It is easy to think of this space as nothing, yet inside that apparent emptiness lies almost everything. Atoms, dust, and stories drift there, waiting for their next shape. In our part of the galaxy, the typical gap from one star to the next is about 5 light-years, tens of trillions of kilometers of near vacuum. To human intuition, that feels like endless absence. But the interstellar medium, the thin material that fills this volume, is the quiet foundation of all that will one day form within it. In each cubic meter, there may be only a few atoms, mostly hydrogen, the simplest element. Yet even those few tell a story billions of years long. Many were born in the cores of ancient stars that lived and died before the sun. Others condensed in the shock waves of supernova explosions, enriched with heavier elements like carbon, oxygen, and iron, the same ingredients that now make up your bones, your blood, the air in your lungs. Every breath you take contains atoms that once belonged to stars. Every drop of water, every bit of carbon in your body was forged in stellar fire and scattered across this great in-between before finding a home in you. The space between stars also holds dust, tiny grains of rock and ice drifting without haste through the dark. These are the ashes of dead stars, the crystalline remains of exploded giants. Over millions of years, dust and gas gather into immense clouds, nebulae that span light years and glow faintly under starlight. Inside these clouds, gravity slowly pulls material together, reshaping empty space into new stars and new worlds. Even apparent emptiness is the universe pausing between breaths. To travel from one sun to another would be to move through this ancient continuum, a place where time feels stretched and silence settles thickly. A ship racing through the interstellar medium would feel a gentle, constant resistance, atoms whispering against its hull. Cosmic rays, high-energy particles flung from distant explosions, would sweep past like invisible rain, requiring shielding not so much from matter as from energy. Yet this thinness is anything but meaningless. In its stillness, the universe keeps its memory. Each atom carries the imprint of what made it, the fusion reactions that formed it, the explosion that freed it, the long drift that delivered it here. To touch this space is to touch a thread that leads through everything that has been and everything that will be. When we look at the night sky, our eyes jump to the stars and ignore the dark. But it is that wide, invisible ocean that gives the lights their context. Without darkness, brightness has nowhere to stand. Without distance, there is no sense of scale or wonder. Without the quiet between suns, there could be no room for stars at all. Through this darkness, invisible particles stream endlessly, relics of dying stars, echoes from distant galaxies. Each one is a messenger carrying the memory of explosions that birthed the elements we are made of. Cosmic rays are the universe's quiet travelers, tiny subatomic particles flung into space at nearly the speed of light, born in moments of extraordinary violence. They rise from the depths of massive stars, from the thin, screaming jets of black holes, from shock waves that ripple through entire galaxies. Long after the brilliant flash of those events has faded, the particles go on, crossing millions of light years, slipping past stars, planets, and the thin clouds of gas between them. They pass through everything, through spacecraft, through atmospheres, through mountains and oceans, through you. Right now, thousands of them are streaming through your body every second, silent and unseen. For most of human history, we did not know they existed. It was only in the early 20th century that scientists noticed a strange radiation that grew stronger the higher they went. Instruments carried aloft by balloons recorded rising levels, not falling. The Earth was not the source, the sky was. What we had stumbled upon was a rain of ancient messengers, still falling from the depths of space. Each cosmic ray carries a small piece of history. Some were forged in the hearts of supernovae, where dying stars explode and fling their ashes into the galaxy. Others may come from even farther away, from active galaxies and quasars billions of light years distant. Their energies are astonishing. A single proton can strike Earth's atmosphere with as much punch as a fast-thrown baseball. When these particles hit atoms high above us, they trigger cascades of secondary particles, invisible showers that ripple down through the air like brief, ghostly rainstorms. In space, without the cushion of an atmosphere, they fly unimpeded. A ship traveling between stars would drift through this cosmic drizzle constantly, its hull sometimes pinged by energetic intruders. Keeping future travelers safe from this steady radiation may be one of the hardest parts of interstellar flight. For every moment of the journey, ship and crew would live inside the galaxy's faint, radiant murmur. Yet cosmic rays are not only hazards, they are also storytellers. By studying their energies and what they are made of, scientists can trace where they likely came from and what kind of stars created them. Many carry heavy elements, iron, nickel, even hints of gold atoms forged when stars die and collide. When these particles finally strike planets or dust and slow down, they become part of a grand recycling. They help seed worlds with the ingredients of life. In that sense, we owe them a quiet debt. The carbon in your cells, the calcium in your bones, the iron in your blood were born in stars. Some of that material rode outward on cosmic rays, drifting for ages before folding into new clouds, new systems, and finally into you. So when you look up at the night sky, remember, it is not empty above you. The air around you is humming with visitors from across the universe, tiny fragments of long-ago explosions that made life possible. The universe speaks softly, not in words, but in particles. If we learn to listen, those whispers tell us something gentle. Even destruction, on a cosmic scale, is just another way the universe finds to create. Until our bodies can cross these distances, our minds already have. Thought has gone ahead as a scout. Every telescope, every simulation, every photon caught by our instruments takes us farther than our feet can travel. Long before any machine touched the border of the solar system, imagination had already slipped past it. Long before Voyager left the heliosphere, we had sketched maps of constellations, dreamed of walking under alien suns, and written stories of faraway shores. The body is bound by gravity, time, and fuel. The mind is not. Thought is the first and fastest vessel we ever launched into the void. Every telescope we build is an extension of that vessel, a mirror of curiosity pointed outward. When the Hubble Space Telescope opened its golden eye above the blur of our atmosphere, it became a quiet window into distances we could not have reached otherwise. Through it, we saw galaxies whose light began traveling toward us before Earth existed. Later, the James Webb Space Telescope joined our fleet of instruments, tuned not mainly to visible light but to the soft warmth of the infrared, the cooled and stretched glow of ancient fire. In those longer wavelengths, star nurseries appear through the curtains of dust that hide them. Young worlds reveal themselves as tiny shadows and subtle colors. The faint signatures of gases in distant atmospheres emerge little combs of lines in the spectrum that whisper of methane, carbon dioxide, and water vapor. Through these tools, we have already crossed many invisible thresholds. We have watched storms swirl on gas giants light years away, traced the faint dimming of stars as planets pass in front of them, and turned those tiny changes in brightness into imagined landscapes. In this way, every observatory is a ship made of glass and electronics. Its mirrors and detectors are our sails. The data they gather is the wind. We launch not bodies, but awareness. Each photon that lands on a sensor began its journey long ago, carrying a message. When that photon finally finishes its flight inside a human-made instrument, it has done something no rocket yet can do: traveled from a distant star straight into a human thought. We also build ships made purely of numbers. Supercomputers create worlds inside themselves, following the rules of physics where we cannot yet go in person. They simulate how planets form, how atmospheres swirl, how galaxies grow and collide. In digital space, we have fallen into black holes and flown back out, walked over Martian canyons, and orbited Proxima b in imagination. The mind lays down paths that technology may one day follow. So even if our physical ships have not yet sailed the interstellar sea, we are already exploring it in the most human way, by understanding it. Our instruments translate the universe into patterns of numbers. Our minds turn those patterns into meaning. In a quiet sense, we are already there, already standing under Proxima's crimson light, feeling, in thought, the warmth of a star 4 years away. Every journey begins, not with metal and flame, but with a question, a tiny spark of curiosity that leaps faster than light, faster than fear. The body may follow one day. The mind is already among the stars. Curiosity is the only engine that never runs out. It burns softly inside us, powering every telescope, every launch, every patient night at the eyepiece. Long before rockets or equations or even language, curiosity was already alive, flickering in the eyes of people who looked up at the dark and felt something pull at their thoughts. They did not have names for the constellations. They did not know what the points of light were, but they knew enough to wonder, what are those fires? Why do some wander? What lies beyond them? That urge to ask is the first real fuel our species ever discovered. Unlike coal or oil or uranium, curiosity only grows as we use it. Every mission begins this way, with someone asking why or what if. The Voyager probes began with a question. So did the Mars rovers, the James Webb Space Telescope, the idea of sailing on beams of light, the first equations that described gravity, the first piece of glass turned carefully toward the sky. Curiosity is not owned by any nation or era. It belongs to anyone who has ever looked up and felt small and alive at the same time. It drove ancient sailors to push their fragile boats beyond sight of land. It drives modern engineers to send delicate machines beyond sight of the sun. It links Galileo nervously pointing a crude telescope at Jupiter with a child tonight staring through a window at the same bright planet. The tools change. The feeling does not. When we say curiosity is fuel, we mean that without it, nothing moves. Without it, science stalls. Exploration shrinks into stories about the past instead of journeys into the future. Every time a rocket rises, it carries metal and circuits, but it also carries the quiet power of countless questions that refuse to go away. Curiosity asks for very little. It does not demand certainty. It lives happily in the space between knowing and not knowing. Even failure feeds it. A broken mission or an unanswered problem is not an ending, but an opening, a sign that there is more to learn. That is why curiosity feels endless. There is no final destination. Even if we reached the edge of the visible universe, we would still turn and ask what lies beyond. That endlessness is not a wall, it is a compass, always pointing onward. One day, if our descendants stand on the soil of another world under another sun, they will look up and feel the same tug we do. The same soft and urgent wondering that began on Earth will move through them. Curiosity will still be their map and their light, because in the end, it is not hardware that makes us explorers. It is the simple, unstoppable question at the center of us. What comes next? Between stars, The temperature sinks to just a few degrees above absolute zero. Yet even here, warmth lingers. The faint afterglow of the Big Bang wraps the universe in a kind of eternal dusk. Far from any star, there is no direct sunlight to warm a ship, no atmosphere to hold heat close, only a vast, thin emptiness. The warmth of our sun becomes a distant memory, a small ember swallowed by the dark. Heat itself turns into something rare and precious, a small defiance against the great cosmic cold. In this deep space, the temperature settles around a few degrees above absolute zero, the point where motion nearly stops and atoms only tremble. It is as cold as reality allows, and yet the universe here is not truly dark or dead. All around, there is a faint, omnipresent glow, the cosmic microwave background, the leftover warmth from the universe's birth. This is the oldest light we know, a whisper from when everything was fire, more than 13 billion years ago. When the cosmos was young, it blazed with heat and brightness beyond imagining. As it expanded, that light stretched and cooled until only this soft, invisible remnant remained, a sea of microwaves bathing every corner of space. Even now, those ancient photons stream through you, through planets, through galaxies, carrying the quiet echo of creation. To sensitive instruments, the entire sky glows at this wavelength, not with the sharp points of starlight, but with an even, gentle brightness that comes from everywhere at once. To exist out in the true interstellar void is to inhabit a silence so deep it feels almost sacred. Every photon of warmth, every stray particle of energy, has traveled for ages to arrive. A single ray of starlight might cross light years of cold before it finally touches a bit of dust or a lonely rock. The emptiness here is not really absence, it is distance, a place where energy simply takes its time. The cold is not cruel. It preserves. It holds the frozen husks of comets, the cooled shrapnel of dead stars, the drifting molecules that will one day gather again and ignite. Within this long, slow chill, creation waits. It is the pause between breaths, the quiet before the next rising note. If your eyes could see microwaves, you would watch the whole universe glowing faintly, not in bright colors, but in a soft, uniform light. Every region of space, from the crowded hearts of galaxies to the seemingly empty stretches between them, would shine with the same ancient warmth. So yes, space is cold beyond anything we feel on Earth. But even here, where temperatures hover just above nothing, the universe still hums with its own history. The cold between the stars is not the end of heat. It is the backdrop against which every flame, every living cell, every warm world stands out. It is the silence that lets the song of the cosmos be heard, a vast, eternal dusk in which every spark still shines. Out here, without landmarks or sound, our only guide is starlight. In the deep silence between suns, there are no roads, no east or west, no rising sun to mark direction. A traveler drifting through interstellar space would find nothing to steer by except the sky itself, a dome of cold, steady brilliance. And yet within that brilliance lies everything we need to find our way. Every star, every beam, every pulse carries a map written in physics, waiting to be read. For thousands of years, sailors on Earth steered by constellations, letting the familiar patterns above lead them across dark oceans. Interstellar navigation is not so different, only the distances are almost impossible to grasp. Each star's position and motion helps weave a vast celestial web, a framework of reference points that stretches across the galaxy. The more precisely we measure their locations and paths, the clearer that web becomes. With missions like Gaia, astronomers have charted the positions and motions of well over 1 billion stars in the Milky Way, sketching the first true map of our galactic sea. But light does more than show where things are. It reveals how they move. When a star drifts toward us, its light shifts ever so slightly bluer. As it moves away, it shifts a little redder. The same Doppler effect that changes the sound of a passing siren turns into a subtle color change in starlight. By measuring those tiny shifts, we can turn faraway stars into speedometers and compasses. Even the smallest wobble in a star's motion can betray the pull of unseen planets or the passing of a gentle gravitational wave. For interstellar travelers, starlight would serve as both clock and guide. Pulsars, the ultra-dense remnants of exploded stars, flash with such reliable regularity that they behave like cosmic lighthouses. Some spin hundreds of times per second, sweeping beams of radio waves through space with the precision of a perfect clock. By comparing the arrival times of their pulses, a ship could triangulate its position anywhere in the galaxy, a kind of galactic GPS powered by the embers of supernovae. Other guides lie in the faint glow that fills all of space. The cosmic microwave background, that ancient sea of light left from the universe's birth, can act as an ultimate reference. Against its nearly uniform glow, every motion and acceleration becomes measurable. Even gravity itself leaves trails to follow, bending the paths of photons as they pass near massive objects, curving their routes through the warped fabric of space-time. In the darkness between suns, light becomes both map and message. A ship bound for Proxima Centauri would not steer by what the human eye can see, but by what its instruments can feel. The slight drift of star patterns, the delicate push of photons, the faint pull of distant masses. Each photon that strikes a detector would be like a soft coordinate, a whisper saying, "You are here." Even in a universe without roads, we are not truly lost. The stars are the signposts, pulsars, the beacons, the background glow the horizon. Navigation becomes less about finding a fixed point and more about remembering what we belong to. A web of light so vast and intricate that every beam is a thread leading home. At very high speeds, that web begins to bend around you. The faster we travel, the stranger time becomes. Einstein taught us that time is not a steady river flowing the same everywhere. It stretches, sways, and slows depending on how quickly we move and how deep we sit in gravity's well. The closer we approach the speed of light, the more that flow twists until time and space begin to feel like different directions on the same flexible fabric. Imagine a ship on its way to Proxima Centauri, accelerating to a significant fraction of light speed. Seen from Earth, the journey might take a little more than 4 years of calendar time at minimum, but on board, the story would feel different. As the ship's speed increases, time for the crew slows down relative to those left behind. Their days lengthen gently, stretching into something broader, while back home, the years roll past. To those aboard, the trip might feel shorter than the distance suggests, perhaps months or a handful of years. They would arrive slightly younger than Earth expected them to be. This effect, called time dilation, is not speculation. It has been measured many times. Particles in accelerators live longer when they move near light speed. Satellites in orbit must adjust their clocks because both their motion and their position in Earth's gravity change the passage of time for them. Even astronauts aboard the International Space Station experience tiny differences in aging compared to people on the ground. On the human scale, these shifts are small, but they hint at a deeper truth. Motion reshapes both distance and duration. At relativistic speeds, even the sky would distort. Ahead of the ship, starlight would bunch up and shift toward intense blues and ultraviolet. Behind, it would stretch into deep reds and infrared. The pattern of the heavens would seem to curve inward toward the direction of travel, like a tunnel of light carved by velocity itself. To move that fast is not just to cross space. It is to slide sideways through time, altering the rhythm in which your life unfolds. If a crew left Earth and reached Proxima at, say, 90% of the speed of light, only a few years might pass for them, while more years slipped by back home. If they turned around and returned, decades could have flowed on Earth, while the travelers experienced far less. Motion would have turned distance into time, and time into something personal and relative. Push the idea even further, and at light speed itself, photons experience no time at all between their creation and their absorption. For them, the journey is a single instant. When we dream about travel to the stars, we often treat it as a problem of distance. In truth, it is also a conversation with time. To go far is to feel how small a human lifespan is, and, at the same moment, how strangely elastic it can become when it rides the curves of relativity. Even if we reach another star, we remain inside the same universe, the same continuous fabric. Every destination is, in a quiet way, an illusion. For as long as we have existed, we have been a species of seekers. We walk, sail, fly, and now orbit to reach places: a mountain peak, a distant island, a nearby planet, a faint star. Each feels like a goal, a point of arrival, but on the scale of the cosmos, there is no final shore. If a ship were to arrive at Proxima Centauri, it would rightfully be seen as one of the greatest achievements in our history. 4 light years of darkness crossed, a new sun reached, yet the view from there would still feel familiar. The constellations would lean and rearrange slightly, but the Milky Way would still arc across the sky. The same distant galaxies would glow beyond. The same cosmic microwave background would hum softly in every direction. We would have crossed a line that exists mostly in our imagination. The universe has no outer wall, no solid edge. Space itself is expanding, carrying galaxies away from one another like dots on an inflating balloon. The farther they are, the faster they recede, their light stretched to fainter and redder hues. Some are already slipping beyond the reach of our telescopes. One day, many will vanish from view entirely, not because they are gone, but because their light can no longer overtake the stretching of space. In such a universe, what does it mean to arrive? Perhaps arrival is not about reaching the end of a journey, but about recognizing where we are. To arrive is to become aware, to see clearly, to listen deeply, to feel that we belong to the thing we are exploring. The real destination of any voyage is understanding. Every step outward, no matter how far, comes back to the same realization. We are not separate from the universe. We are pieces of it, made from the same atoms, moved by the same laws, carried by the same expansion. So even if, one distant day, people stand on the ground of a world circling Proxima Centauri, feel an alien wind on their faces, and watch a red sun rise above unfamiliar hills, they will still be living inside the same grand whole, the same cosmic story, continued on a different page. Arrival will not end exploration, it will deepen it. There is no final harbor, only an endless sea and our quiet insistence on crossing it. And then, after all the maps and equations and imagined paths, comes the moment when a distant point of light begins to swell. At first, Proxima is only a slightly brighter ember against the starfield, one more dot among many. For years, from the ship's perspective, it barely seems to change. A steady pinprick on the forward sky, but little by little, almost too slowly to notice, it grows. Its glow spreads, deepens, reddens. What was once just a mark on a chart becomes a destination, a lantern, a kind of promise hanging in the dark. The ship's sensors feel it before human eyes do. Instruments register a slight rise in infrared light, a hint of extra warmth brushing the hull. Numbers on screens shift, graphs climb. Then, through a window or a display, someone sees what the data already knew. The void ahead is no longer empty. We are approaching another sun. Proxima Centauri, for so long just a name in books and a dot on maps, appears now as something real. The photons now striking the ship's metal skin left the star years before the journey began. They set out before engines roared, before anyone on Earth whispered their first farewell. Only now, after all the distance in between, do they arrive, meeting the travelers at exactly this moment, as if time itself has been patiently arranging their encounter. As the star grows in the viewport, its color deepens into a rich crimson. It does not blaze like our own sun. Its light is softer, less overwhelming, more intimate. It glows like a breath held in the dark. Around it, more detail emerges. A faint veil of dust, the hint of something small and dark moving against its face. Perhaps a world. Every instrument on the ship leans in, so to speak. Spectrometers split the light into rainbows of information. Cameras adjust exposure. Antennas tune to new bands. The ship is hungry to taste this star, to learn its rhythm and the secrets hidden in its glow. For the people who make this journey, or for those back on Earth who share it through streams of data and images, this is more than a technical success. It feels like a kind of quiet, cosmic ceremony. Humanity has crossed the black gulf between stars, following nothing but equations and a tiny point of light, and the universe has answered with a new sunrise. It is as if the cosmos has reached out in return, meeting us halfway to remind us that we were never entirely alone in the dark. And under that red glow, there is a complicated tenderness, awe at what we have reached, and homesickness for what we left. In the light of Proxima, we see both a beginning and an ending. A new sun gained, an old sun forever behind us. Every arrival carries the ghost of a departure. The engines still hum, the instruments still click and record, but for a brief, shared moment, there is only stillness inside the ship. A pause, a breath, the realization that something once thought impossible has quietly become real. We have followed a distant ember across an ocean of night and found, at last, another dawn. Light has returned, and with it comes the gentle reminder that no matter how vast the dark may seem, there will always be another horizon waiting to shine. Proxima is not alone out here. It belongs to a small family, the Alpha Centauri system, 3 stars bound together by gravity and time. Most stars in our galaxy are not solitary like our sun. They live in pairs or trios, moving in long, intricate dances. Proxima Centauri is the faintest, smallest sibling of a magnificent trio. Its 2 companions, Alpha Centauri A and Alpha Centauri B, are a close pair of golden stars. They circle one another in a tight, graceful loop, trading places in a slow dance that takes many decades to complete. Far beyond them, on a much wider path, Proxima drifts like a quiet ember, keeping its distance and yet never quite leaving. Light from A and B takes many days to reach Proxima, but their pull is unbroken. All three are held together by an ancient, invisible bond. Imagine standing on the surface of Proxima B, looking up into that alien sky. The main sun would be Proxima itself, a dim red disk hanging low and large, appearing bigger than our own sun does from Earth, but shining with far less brilliance. Its light would not be white or golden, but a deep, soft crimson, washing the world in shades of rust, copper, and wine. Far off, near the edge of sight, two tiny sparks might rise together from the horizon, Alpha Centauri, A and B, shining as twin points of pale gold. On some nights, they might climb the sky side by side, casting a faint double glow, bright enough to sketch soft twin shadows across rocks and waves. On other nights, they would drift apart, wandering in slow patterns that repeat only over years. For any eyes looking up from Proxima B, these distant suns would be a reminder that even in a quiet red world, there is a larger family out there. From afar, the sight of the entire system would be breathtaking. Two golden stars swirling tightly around one another, and far away, a small red star tracing a long, lonely orbit, like a lantern on the edge of their shared gravity. Proxima may be the dimmest of the three, but it completes the chord. It is the third note that turns a simple pair into harmony. To picture such a system is to imagine a world ruled by strange rhythms. Seasons would not be set only by tilt and orbit, but by the changing positions of three suns. The sky would be alive with movement, shifts in color, in brightness, in the pull of gravity itself. Time for any living things there would be written in light, the crossing of one star behind another, the slow brightening and fading of distant companions, the long stretch of twilight that could last for ages. Closer to the ground, Proxima B itself is probably a world of deep contrasts. Because it orbits so near its star, its rotation is likely locked. One face always stares into Proxima's red glow, and the other face is turned forever away. On the day side, the star never moves. It hangs in one fixed spot in the sky, pouring down a constant crimson noon that never cools. On the night side, the star never rises. Darkness reigns without dawn, save for the faint glimmer of starlight and perhaps a distant gleam from Alpha Centauri A and B. Between those extremes lies a ring of possibility, a narrow band of eternal dusk where day and night meet in fragile balance. Along this twilight circle, warmth from the bright side and cold from the dark side mingle. Winds would forever rush from hot to cold, carrying heat across the border, carving great streams of air around the planet. There, temperatures might hover near the line where water can stay liquid. Ice from the night could melt, and vapor from the day could condense and fall as rain. Imagine standing in that dusk zone. On one horizon, the red star burns low, a dim but steady glow painting the sky in copper and violet. On the opposite horizon, night thickens into deep black, already sprinkled with stars. Above you, the sky never fully brightens and never fully darkens. Shadows stretch long and thin. There is no morning, no evening, only an endless, gentle in-between. Tidal locking is thought to be common around red dwarfs like Proxima. Their habitable zones lie close in, and their gravity slowly slows a planet's spin until it matches its orbit. Our own moon is the same, always showing one face to Earth. On Proxima B, this has likely been true for ages. one side staring into red light, the other sleeping in shadow. And yet, that does not rule out life. It simply reshapes where life can hide. In the twilight ring, energy and stability come together. If Proxima b has an atmosphere, it could smooth out the worst extremes, carrying warmth toward the dark side and allowing oceans or lakes to persist. Clouds might gather above the dusk line, their shapes fueled by the constant push and pull of hot and cold. They could rain in slow cycles, feeding rivers that flow toward both light and night. Plants, if they have taken root there, might stretch wide leaves or fronds toward the red sun, tuned to drink in every faint photon. They might be deep crimson or nearly black, colors chosen by evolution to grasp the star's dim warmth. Creatures, if they wander that world, might migrate along the circle of twilight, forever following the line where conditions are kindest, never venturing too far into glare or ice. There is something quietly moving in the thought of such a planet, a world divided by light, yet united by a thin band of balance. At the extremes, there is a frozen silence and a scorched glare. In between, there is a narrow ribbon where possibility blooms. If Proxima b has kept its atmosphere, the sky above that ribbon could be astonishing. An atmosphere is more than air. It is a shield, a lens, and a memory, all at once. It records eruptions and storms in its chemistry, and it softens the harshness of space into clouds and weather. For a planet so close to a temperamental star, holding on to air is a delicate achievement. Red dwarfs are generous in lifetime but harsh in temperament. Their long, slow burn can warm worlds for trillions of years, yet their flares are fierce. Bursts of high-energy radiation can strip gas from a nearby planet, tearing molecules apart and blowing fragments into space. Each flare is a trial. For Proxima b, every eruption is a test of how strong its atmosphere and magnetic field truly are. If the planet has a magnetic field like Earth's, it might still be safe beneath the storm. A strong magnetosphere can catch and steer charged particles, guiding them toward the poles instead of letting them slam directly into the air. Where those particles fall, they collide with atoms and molecules, turning invisible energy into shimmering curtains of light. Imagine looking up from the twilight ring and seeing auroras that stretch from horizon to horizon. Not just gentle green bands as on Earth, but towering rivers of crimson, violet, and pale emerald, flowing across the entire sky. Each flare from Proxima would send new waves of light dancing overhead, painting the perpetual dusk in motion. The storms that feed them would be dangerous, but their beauty would be overwhelming. A world glowing from within, lit by the breath of its own star. If the atmosphere is thick, perhaps rich in gases that trap heat, it could both protect and nurture. Clouds might form in vast belts around the terminator, reflecting red light into soft shades of rose and amber. Winds would never tire, forever chasing balance around the globe. In that restless air, tiny chemical clues might drift, hints of oxygen, methane, or water vapor. They would be subtle, delicate fingerprints of processes happening far below. From Earth, astronomers search for those fingerprints. They watch carefully as a planet passes in front of its star, measuring how the starlight changes when it filters through a thin shell of air. A small dip in certain colors can reveal what the atmosphere is made of. It is a quiet, patient art, reading the stories written in a few missing wavelengths. To detect an atmosphere on a world 4 light-years away is difficult. It takes years of data, sensitive instruments, and a shared decision to keep looking even when the signal is faint. But the reward is immense. To know that Proxima b has air is to know that it has shelter, and where there is shelter, there is a chance for life to take hold. Beneath those skies, there might be water. Perhaps not in familiar blue, but in a palette shaped by a red sun. Water is the simplest and most powerful architect of life that we know. It dissolves, carries, blends, and remembers. On Proxima b, liquid water, if it exists, could glow with strange colors, reflecting the stars' deep crimson into copper and rose. Picture an ocean under a perpetual dusk. The waves are dark, heavy mirrors, picking up glints of red and gold from the low sun and the distant twin stars. In the shallows, the light might be warm and wine-colored. In deeper regions, where blue light never existed to begin with, the sea would fade into a velvety maroon night. Life in such waters would adapt to that strange spectrum. Perhaps delicate, translucent organisms hover near the surface, catching the faint warmth. Deeper down, shapes might glow with their own light, tiny sparks of bioluminescence tracing constellations beneath the waves. Vents on the seafloor could pour out heat and minerals, feeding communities that care nothing for starlight at all, as they do around our own ocean vents. Currents would be driven by the great contrast between day and night. Warm water from the star-facing side would flow toward the frozen dark, where it cools and sinks, then creeps back again along the deep. The twilight seas would lie over this slow, planetary heartbeat. Above, clouds may build into towering red-lit storms, where warm air rises from the dayside, condenses, and falls as slow, heavy rain. If such oceans have existed for a long time, they have had time to change, to experiment, to grow more complex. Not necessarily into minds or cities, but into networks of chemistry and cells, quiet and persistent. Life there would know nothing of blue sky, of bright white noon, of cold starlight. It would know only the gentle weight of water and the steady glow of a red sun. And if, someday, we learn that those seas are real, that Proxima b truly holds oceans under its crimson sky, it will feel like more than a scientific fact. It will feel like a conversation, the meeting of two worlds, shaped by two different stars, reflecting one another across the dark. Our own oceans, silver under a yellow sun, theirs, copper under a red one, both built from the same simple molecule, both cradle to whatever stories their worlds can tell. Even across 4 light-years of space, the dream of water persists. It is the universe's oldest memory, and perhaps its most beautiful promise. If life exists there, it has never heard thunder, never seen blue. It would have grown up in crimson twilight, under a sky that never truly brightens and never truly darkens. The silence would run so deep that even sound itself might feel sacred. On Proxima b, everything would likely move slower, softer. If there is air, it may be dense and heavy, pressing gently on every surface, muffling each vibration before it can travel far. The oceans, if they exist, would roll in long, heavy swells beneath a permanent dusk, their voices swallowed by the thick atmosphere. No brilliant lightning storms cracking open the night, no roaring wind tearing through forests, no great crashes of thunder shaking the sky. Instead, there might be a hush that never lifts, an eternal calm stretched across a world that has never known the constant chatter of birds, rivers, and cities as we do. Life there, if it has taken root, could grow in rhythm with that stillness. No creature would need to shout across distance. No leaves would rustle in wild gusts. Communication might take gentler forms, slow waves of scent, shifts in temperature, changes in color. patterns of bioluminescent light. Sound might be rare or precious, something used only for moments of great importance, the way a bell rings in a quiet chapel. On Earth, we are surrounded by noise, wind in trees, waves on shores, insects buzzing, engines thrumming, a constant symphony of motion. Our planet hums and roars and sings. On a tidally locked world under a dim red sun, there may be no such thing as a daytime soundscape. If there are forests, they might sway in near silence. If there are seas, they might murmur only faintly, their voices dulled by the weight of the air. Even footsteps, if anyone ever walks there, could fade almost instantly into the dust. Yet silence does not mean emptiness. It means attention. On such a world, the smallest motion might be profound. A single droplet falling from a leaf, a bubble rising to the surface of a dark sea, a gentle tremor in the soil. Life might experience existence not through the loudness of the environment, but through subtle vibrations, changes of pressure, faint glows of light, the pull of currents and gravity. It might feel the universe more than hear it. If you could stand there beneath Proxima's dim red glow, wrapped in air thick as velvet, your own voice would sound strange to you. Words would not carry far. They would soften and dissolve after only a few meters, swallowed by the atmosphere. You would hear your own breathing more than anything else, the simple rhythm of life in your chest. In that quiet, your heartbeat might sound like thunder to your own ears. Perhaps such silence would not feel like absence, but like reverence, a kind of planetary meditation. Life could evolve without hurry, shaped by long stretches of calm rather than constant urgency. Movements would be deliberate. Changes would take their time. Existence itself might slow to match the gentle pulse of that small red sun. If awareness ever arose there, if some being looked up at the same crimson sky and wondered as we do, its thoughts might be woven from the stillness around it. Its language might not be spoken, but seen. Soft flashes of color, shifting patterns of glow, slow ripples of light across skin or air. The quiet of Proxima b would not be empty. It would be deep. It would be a world listening more than speaking, in constant, quiet conversation with its star, its seas, and its endless dusk. And then, one distant day, something impossible might arrive. When we finally come, if we do, we will be the strange ones. Beings of harsh white light and quick movements, forged under a bright yellow sun, stepping onto a world that has never known our kind of sky. For so long, we have looked up and whispered, "Are we alone?" But there is another side to that question. What happens when we are the ones who appear in someone else's sky? We would come as visitors, fragile and curious, carrying the memory of a different star in our eyes. Our presence would break every rhythm that world has ever known. Our engines would rumble like distant storms. The hum of our machines would sound like thunder in a place that has never heard it. Flashing lamps and cutting beams would slice across a twilight that has never been pierced so sharply. Even our lifetimes would be strange there. We are brief. A few decades of awareness, a little longer if we are lucky. To a patient world under a long-lived red sun, we would be flickers bright, hurried sparks that appear and vanish while the star hardly changes. Imagine setting a boot down on that soil for the first time, under a sky of copper and violet, with Proxima glowing low and steady. Your shadow would fall long and dark on ground that may never have felt a footstep before. The air, tuned to gentle motions, would swirl oddly around the heat of your body. Dust that has rested for ages would lift and drift, carrying the imprint of your arrival. We have always imagined aliens as beings utterly unlike us, but in the mirror of the cosmos, we become the strangers. We are the ones who leave our birth world behind, who arrive under foreign suns with unfamiliar tools and unfamiliar microbes clinging to our skin. We bring with us an entire miniature Earth, bacteria from our oceans, spores from our forests, traces of our air and water and chemistry traveling inside us. The question is not only what we will find, but how we will choose to be found. The hope is that we will arrive not as conquerors, but as carriers of light, fragments of one star reaching out to greet another. If we ever walk on Proxima B, perhaps our first act should be simple, not to plant a flag, but to stand still, to kneel in the red dust and listen, to let the silence press against us until we can feel what this world has been saying, very softly, for a very long time. To any watcher, whether a living mind or a machine, we would look improbable. Fragile creatures wrapped in metal and fabric, hearts beating quickly, thoughts racing faster, crossing a distance their world may never have imagined crossing. First contact, in any direction, may always feel like this, not a flash of revelation, but a gentle reflection. The recognition that, across time and space, the visitors are always the same at their core, small, curious beings, reaching for something greater than themselves. When we stand under Proxima's red sun, the word alien may begin to lose its edge. We will feel, in our bones, that we were never separate from the universe we sought. We were always made of its dust, warmed by its stars, guided by its gravity. We were always part of the story we thought we were only reading. And as travelers, we will almost certainly carry a message. Every great voyage we have ever launched has included one. The Voyager spacecraft each carry a golden record, a thin disc engraved with sounds and images from Earth, greetings in many languages, the rush of wind and ocean, the heartbeat of a mother and child, laughter, music. It is a small, fragile time capsule, now drifting in the dark, waiting for a listener who may never come. Those records remind us of something essential. Even when we cannot go ourselves, we send pieces of who we are. If we ever reach Proxima, we will bring that same impulse. The wish, not just to explore, but to be remembered. Perhaps we would leave behind a small monument, tucked into rock or orbit, with no claim of ownership, only a message. We were here. We came from another star. We wondered about you. It could be etched into metal meant to endure, or encoded in crystals, or beamed gently into space once every 100 years, a quiet heartbeat of civilization. A reminder to whoever hears it that, across the dark, someone once cared enough to say hello. What would such a message contain? Lists of facts about our world, or something simpler, a story, a picture, a clue to what it felt like to be human? Maybe it would say that we were creatures from a small blue planet, that we loved, feared, built, and sang. That we crossed the dark not to conquer, but to connect. We often imagine these messages as gifts to strangers, but they are gifts to us as well. They show that we once chose to leave traces of hope instead of monuments of power, that at least part of us believed our brief spark of awareness was worth sharing. If one day another civilization, biological or mechanical or something we cannot imagine, finds our message, they will know this much, that across 4 light years of silence, a small species dared to send its voice. And then, after everything, after the journey, the landing, the listening, there is the act of looking back. From Proxima Centauri, our sun would be just another star, a faint golden point among countless others scattered across the dark. All the colors of our oceans and forests, every city and storm and story, every life that has ever unfolded there would be folded into that one tiny spark. It would not stand out. You would know it only because you remember it. From that distance, all the boundaries we draw across its surface countries, continents, lines in the sand, blur into nothing. What remains is a single world, a single light, astonishingly small and unbearably precious. This is the quiet gift of going far, not escape, but clarity. We chase other suns and other skies so that we can better see our own. When you stand at the edge of another star's domain and turn back toward home, you feel, in a way words can barely touch, how rare your birthplace is. The air that cradled you, the warmth that raised you, the gravity that has held you close all your life, none of it is guaranteed elsewhere. Each is a miracle of balance. Looking toward our sun from Proxima's realm, you would see light that left home 4 years ago. The people who watched your ship depart would have lived through 4 cycles of seasons. They would have changed, grown older, perhaps moved on. Some may no longer be there to greet you if you return. The light reaching your eyes would show you not the earth that is, but the earth that was. The faces that waved farewell when you left would have aged, changed, grown, perhaps vanished. The earth you remember no longer exists exactly as it was. The clouds have shifted, forests have grown and fallen, cities have brightened and dimmed, lives have begun and ended. And yet, in this moment, from Proxima's realm, you can still see that earlier version of home. Time and distance fold into a single image, carried by light. What you see is not the present Earth, but the memory of one, written in photons. The perspective runs both ways. From Earth, we gaze toward Proxima Centauri and imagine the unknown. From Proxima's sky, we look back and remember the familiar. 2 directions. One truth. The universe does not care about here and there. It offers only everywhere. An endless field where positions are temporary and roots are many. Every world, every star, every atom belongs to the same unfolding story. In that story, our sun seems modest, just one star among hundreds of billions. Yet, as far as we know, it carries something rare. Around this small yellow lantern, matter learned how to think, how to feel, how to name the stars that made it. Our sun is not just a sphere of plasma. It is, for us, a lantern of consciousness, a point in the dark where the universe has become aware of itself. So when we look back across the interstellar sea, that tiny spark is more than a point of light. It is laughter and arguments, the taste of fruit, the sound of rain against windows, the smell of pine after storms. It is the warmth of another hand in yours, the first stories told around fires, the first child who ever pointed at the sky and asked why. From Proxima, our sun may appear small, but to us it is limitless, because in all the silence of space, that light is our reminder of belonging. Each star we reach becomes the starting point for another journey. Exploration is not a single mission. It is a rhythm, a slow heartbeat repeating across the galaxy. The universe has no true center, only continuations. Every arrival is already the beginning of something else. Each discovery is a seed for the next question. When we look up and trace the Milky Way's silver river, we are not only seeing stars, we are seeing stepping stones, suns calling softly to one another across immense stretches of time. Our first imagined voyage from Earth to Proxima Centauri is only a first heartbeat in that rhythm, a small note in a song that began long before us and will continue long after. If one day people live beneath Proxima's red light, they will, in time, look outward again. From that world, Alpha Centauri A and Alpha Centauri B will shine bright and inviting, twin fires on the horizon of thought. The same question that stirred us on Earth will rise there too. What lies beyond? Curiosity does not stop when it finds an answer. It widens. It is the same quiet pull that gathers gas into stars and stars into galaxies. In ages yet to come, our descendants may spread from Proxima to other systems, to a quiet star like Tau Ceti, to the orange glow of Epsilon Eridani, to the compact family of TRAPPIST-1, and many more. Each will become a new outpost of wonder, a place where someone steps outside and feels a different sun on their face. They may build ships that cross distances in days instead of decades, or send minds ahead of bodies as streams of information, weaving themselves into new forms. As they travel from world to world, they will carry stories of where it all began. A small blue planet, circling an unremarkable star where molecules once learned how to dream. Every star we reach will become another lighthouse in the dark, a place where life pauses to listen before moving on. With each new world, our understanding will deepen. We will start to see the pattern more clearly. Stars forming, burning, and dying. New stars kindling from the ashes of old ones. Planets gathering around them in endless variations. Our travels will not stand apart from this cycle. They will be one more expression of it. We will be the universe learning to cross its own distances. Perhaps one night, when the spiral arms of the Milky Way are dotted with the faint signs of many civilizations, it will become obvious that exploration was never truly about conquest or even about discovery. It was about continuity, about the simple instinct to reach, to learn, to move, the heartbeat of creation playing out through conscious beings who dare to follow it. Even now, that rhythm is already active. Photons from distant suns touch our telescopes. Signals whisper through the void. Human imagination stretches between those points of data and fills the gaps with possibility. The chain of suns has begun to pull us forward, link by link, long before our ships are ready. There may come a time when our descendants do not all live under one sky. There will be children of many suns, scattered across wide distances, connected more by stories than by roads. Home will no longer mean only one world. The blue marble of Earth will become a legend, a name woven gently into lessons taught in orbit around other stars. The future of humanity, if we persist, will not be fixed to a single planet. It will be spread among countless worlds, each one shaping the people who live there. Imagine generations born under red suns, white suns, cooler orange ones, some who grow up under domes, watching artificial dawns unfold against glass. Others who see their first sunset as a wash of violet over an alien sea. Their constellations will be unfamiliar, their maps drawn from new skies. They may never smell rain on soil as we know it, or see light scattered through a blue atmosphere, but they will know something else, the feeling of belonging to the stars themselves. On one world, perhaps beneath Proxima's soft auroras, people might farm in crimson light, warmed by mirrors and captured energy. On another, orbiting a brighter star, cities might float on slow, endless oceans. On a frozen planet, communities might live in caverns, carved beneath ice, listening to the slow shifting of their world and calling it comfort. Time and gravity will shape them. Their bodies may adapt, Their languages diverge. Their myths take on different colors. Human will become a wide family of forms and cultures, all descended from the same small beginning. Communication between such distant branches will be slow, limited by the speed of light. But the stories will still travel, somewhere, in songs, in art, in quiet archives. They will preserve the tale of the first leap from Earth to Proxima, not as a mere mission, but as the moment we chose not to stay in one place. Their history may be measured not only in years, but in distance. How far the signals of their ancestors have spread, how many suns now hold the echo of a human voice. When they speak of family, they may mean everyone, everywhere, who can trace their origins back to that pale blue world near a modest yellow star. There will be no single civilization then, but a constellation of them, a web of light and culture spanning the stars. Some groups may forget parts of their origin story. Others will keep it alive in paintings and poems. All will feel, somewhere deep within, the same pulse that carried us from oceans to plains, from plains to planets, and from planets to the spaces between them. The future that waits between stars is not a single destination. It is a continuity, a next verse in a song that began the first time someone looked up and wondered. When our descendants gaze across their many skies, they will not see separation. They will see connection, a living network of suns, each one holding a whisper of where it all began. And very far away, faint but steady, Earth's light will still shine, the first spark in a galaxy of children learning to call the cosmos home, because the moment we touch another star, we will look beyond it. That is our nature. We are travelers by inclination, dreamers by design. The universe, in its quiet way, is our reflection, wide, changing, and awake. It has always been like this. From the first humans who crossed unknown seas guided only by starlight, to the scientists who now sift through faint signals from the edge of time, we have never stayed still for long. Each discovery opens a new question. Each arrival hides a departure inside it. Even standing under a new sun, humanity will tilt its head and look toward the next. The urge to explore is not only about need or survival, it is something more fundamental, woven into whatever awareness is. When we look at the stars, we are looking into a mirror. Every spark of light is a reminder of the same fire that burns in us, the desire to exist, to grow, to understand. We are, in a quiet and literal way, the cosmos, becoming aware of itself. Atoms forged in long-dead stars, now arranged into minds that can remember, imagine, and care. In the end, the journey is not only about crossing distance, it is about awakening. Each step we take into the dark carries a little light with it. Each question we ask illuminates one more corner of the unknown. Maybe that is the true purpose of the stars in our story, not simply to be reached, but to remind us that we are part of something immeasurable, something that is always still unfolding. We began under a familiar sky and learned, little by little, how to travel outward. We left the thin blue veil of Earth, crossed the orbits of our neighboring worlds, and sent fragile machines beyond the heliosphere into the solemn, deep space between suns. We imagined engines that burn like tiny stars, sails that ride on light, and miniature craft that carry our curiosity farther than our bodies yet can. We traced the soft red glow of Proxima Centauri and the fragile possibility of Proxima b, a world of permanent day and permanent night, where life might cling to a ring of eternal dusk. We listened to the quiet streams of particles and the slow tides of gravity, and felt, from far away, how precious our own world is, And now, here, at the close of this journey in imagination, you can let the story rest. Let the thought of distant suns drift gently to the edges of your mind. Picture, if you wish, a calm red twilight over a still ocean on Proxima b, and somewhere far behind it, a tiny golden star that once was home. Feel how the universe holds both at once. You are safe where you are, on Earth, under your own sky, with your own warmth close around you. The stars will continue their slow conversations. The light will keep traveling. Curiosity will keep moving through countless minds. For tonight, you do not have to follow it. You can let your thoughts soften, like starlight fading into dawn. Let the cosmos become a quiet backdrop, a gentle presence just beyond closed eyes. Somewhere between the memory of home and the dream of other worlds, you can drift into sleep, carried like everything else on the calm, patient tide of the universe.